Hello, welcome friends, me Anila. The topic of my discussion is about electronic configuration. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to write an electronic configuration, how electrons are revolving around orbits and orbitals, in which way I will tell you in this video. For the electrons to be filled in orbitals, there are three steps. Step number 1. Electrons fill orbitals in this order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Because 1s has lower energy, 2s has higher energy, 2p has much higher energy, and we move forward, the energy is increasing. Electrons fill orbitals in this order. This is Aufbau principle in my previous video. In Aufbau principle, the electrons fill orbitals in this order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Here 1, 2, 3, 4 are shell principal quantum number. S, P, D, and F, these are azimuthal quantum number. Step 2. Maximum number of electrons in each subshell is, here I have written subshell and maximum electron that it can hold. S orbital, as I have discussed earlier, it is spherical in shape. It can hold 2 electrons. P orbital can hold 6 electrons because P orbital has 3 subshells, each containing 2 electrons, so total of 6 electrons. D orbital containing 10 electrons because D orbital consists of 5 subshells, each containing 2 electrons, so total of 10 electrons. F orbital, that is consisting of 7 orbitals, each containing 2 electrons, a total of 14 electrons. So maximum number of electrons in each subshell is this. Step number 3. Add electrons according to atomic number. Because atomic number is number of proton, so according to number of protons, we will fill electrons according to atomic number. Now, example number 1. Write an electronic configuration of iron. Iron is a transition metal and it has atomic number is 26. You have to memorize it. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So first we will write 1s according to Aufbau principle. Then 1s has lower energy, 2s has higher energy, 2p has much higher energy, so on. So according to Aufbau principle, we will write principal quantum number and subshells. I have discussed in previous slide that s orbital can hold 2 electrons. So 1s2, 2s2, p orbital can hold 6 electrons. 2p6, 3s2, s orbital can hold 2 electrons. 3p6, p orbital can hold 6 electrons. 4s2, s orbital can hold 2 electrons. Because atomic number of iron is 26, so if we add the electrons 2, 2, 6, 2, 6, 2, now 6 electrons are left. We will put in 3d. The maximum electron 3d orbital can occupy is 10 electrons, but here atomic number of iron is 26, so we will write 6 electrons. And because d orbital has 5 subshell, each containing 2 electrons, total of 10 electrons. But in this case, there are 6 electrons in d orbital. That means 4 electrons are unpaired. So iron is paramagnetic because it has 4 unpaired electrons. Paramagnetic means that unpaired electrons show paramagnetic behavior. You can say that it is attracted by magnetic field. So iron is paramagnetic. If we take example of iron plus 2, so 2 electrons are removed from 4s. So it is also paramagnetic. If you take the example of iron plus 3, 2 electrons will remove from 4s, 1 electron removed from 3d. So total 3 electrons are released, and iron plus 3 is also paramagnetic because of unpaired electrons. Example number 2. Write an electronic configuration of zinc. Zinc is also a transition metal. Solution. Atomic number of zinc is 30. That is, first we will write orbitals according to Aufbau principle: 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on. Because atomic number of zinc is 30, we will put electrons according to the subshell. Now, s orbital can hold 2 electron, 1s2, 2s2, 2p, 6p orbital can hold 6 electrons, 3s2, 3p6, 4s2, and 3d 10. Total electrons we will count, it becomes 30. So the 3d orbital consists of 5 orbitals containing 2 electrons, a total of 10 electrons, and total of 30 electrons. So zinc is diamagnetic because all electrons are paired. In the d orbital, 5d orbital, each orbital can hold 2 electrons. So 5d orbital can hold 10 electrons. So all electrons are paired according to Hund's rule. So zinc is diamagnetic because all electrons are paired. Because zinc is diamagnetic means it is repelled by a magnetic field. If we take an example of zinc plus 2, then 2 electrons from 4s2 will be released. In that case, zinc 2 is also diamagnetic, that is repelled by a magnetic field. Example number 3. Write an electronic configuration of oxygen, a vital element. Solution. Atomic number of oxygen is 8. That is, first we will write atomic number of oxygen is 8. That is, we will put 8 electrons. So we will start with 1s, 2s, 2p according to Aufbau principle. S means spherical subshell, P means dumbbell subshell. So we will put 2 electrons in 1s, 2 electrons in 2s, and because remaining electrons are 4, 4 electrons in 2p. Because p orbital consists of 3 subshell, each containing maximum of 2 electrons, but here is 4 electrons, so 2 electrons are unpaired. So oxygen is paramagnetic because it has 2 unpaired electrons. That means it can be attracted by a magnetic field. Example number 4. Write an electronic configuration of sodium. Solution. Sodium is an alkali metal. Solution. Atomic number of sodium is 11. That is 1s2, 2s2, 2p6, 3s1. First we will write 1s, 2s, 2p, 3s and so on, the sequence according to Aufbau principle. Then we will put electrons according to atomic number. S orbital can hold 2 electrons, P orbital can hold 6 electrons. So here total 11 electrons, so 3s has 1 electron. So sodium is paramagnetic because one unpaired electron, that means it is attracted by a magnetic field. On the other hand, if we take example of sodium plus 1 electron is released. So sodium plus 1 is diamagnetic because all electrons are paired. In this way, we can write an electronic configuration. Here we have discussed Augsburg principle, Hund's rule, Pauli exclusion principle, and the 4 quantum numbers. One is principal quantum number 1, 2, 3, 4. Second is azimuthal quantum number, which represents the shape. S orbital has spherical shape, P orbital dumbbell shape, D orbital cloverleaf shape, and F orbital complex shape. Magnetic quantum number, orientation of orbitals in space, and spin quantum number, that the electron has plus half or minus half spin. In this way, we can write an electronic configuration, how electrons are revolving around orbitals and subshells. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.